All right. So okay, then I'll just continue along. Um, all right. So essentially, we've defined what a neural network is, right? A neural network is something that contains a network of neurons. So now we'll come to the parameters of a neural network. So we know that so we have here in this diagram, each of these three circles represent a neuron. So you can think of each of these three circles as holding a number, each of them, right? And let's say that these the inputs to these numbers are fed in by some sensory organs. So some input data, as you might call it, gives values to these neurons, right? And once these neurons have some data information associated with them, they in turn influence output neurons by sending information through these arrows represented here. And some of these arrows will be thicker than the others, in the sense that some of these arrows will allow more information transfer between the blue and the green neuron. So some of these relatively some of these blue neurons will influence the green neuron more than the other. So the relative amount of information transfer importance associated is called a weight. Similarly, now unfortunately in real data, there are a lot of prejudices associated in real world data. For example, some data from our eyes may be perceived differently from the data in our ears, right? So to assign relative importance between these different types of input data, we assign what is called a bias to each of these individual neurons to account for that fact, to see what is the relative importance you give to a certain information in a neuron relative to the other. So finally, let's look at the procedure in brief, right? So the procedure follows like this: take existing data, your given data, and let your model make mistakes like the baby, right? Let your model touch fire and try to see what happens. Second, make an estimate of how bad your predictions are. So how badly do you think you were burnt by the fire, right? Your in that case, your neuron, your neural organs are telling you how bad the pain is, and essentially are giving you a feedback to the actions you are making, right? So make an estimate similarly, and finally tweak your parameters of the model to minimize this estimate of how bad your predictions are, right? So an estimate of how bad your predictions are is what is called a cost function. Essentially, it is a function that tells you, uh, given a certain set of parameters, I just described what parameters are, right? Weights and biases, basically things which influence information transfer between two neurons. What is the dependence of how bad my prediction is on these weights and biases? Essentially, if I make certain choices in my life, what do you think is going to be my feedback, right? If I make some certain bad choices in my life, I know that things things that happen to me won't be good, right? I'll end up suffering. So what is the magnitude of that suffering relative to what kind of choices I make is something that the cost function tells you. So by the way, the image on the left here is a neural network, and you can see many different neurons, these circles holding information, and you can see information transfer between two different layers of neurons, as we call them. And you can see that information progresses from one end to the other. We'll talk about that a little bit now. So basically, this image on the left is basically credits to 3 Blue 1 Brown. He's a YouTube channel which has excellent videos on neural networks. So the idea is that given some input data, right, all these circles here, empty circles, will hold some number, right, as I mentioned, that contains some information about the input data. Now what we do is we want our final predictions to be again neurons containing some certain values about what we'd like to predict, right? So for example, if you wanted to predict okay, I'll come to some examples later when we look at our hackathon. But the idea is that the information contained in the initial input neuron layer is then propagated to the next neuron layer called the hidden layer, and so on and on until we reach the output layer. And the output layer is what contains all the predictions. So this is the process of forward propagation of information, and this is called the forward pass. So input neurons essentially take in data and pass them forward through these weights. Remember, the weights that we discussed about the importance of information transfer are the ones here outlined in different colors. So can anyone see any problems with this method? I'll wait for some time. But does anyone have any questions until now? Okay, fine. Then I'll just continue along. So basically, so some problems with this right now, our model as of now, is the fact that our weights are just random numbers at this point, right? So our baby hasn't learned anything yet. We are just randomly guessing, right? All of this fancy architecture about neurons, hidden layers, output neurons, weights, biases, and there are some things I haven't talked about called activation functions, right? All of this setup is just ending up predicting random values at the end, because all of our parameters that we're using in the model are all random, right? So our predictions don't make any sense as of now. So, and that's the point I was trying to make a few slides ago when I said, let your model make plenty of mistakes, right? Let your model make terrible predictions. Now what we'll do is we'll try to teach the model, right? Just like how the fire is painful to the baby, or parents might discipline a baby for doing something wrong. We need to discipline our model, or train our model as it's called, to make better predictions than what it's currently doing. So to do that, we need an estimate of how bad our model is performing. That is called the cost function. So the cost function essentially tells you how bad is our baby at prediction, right? So any cost function will be some error between your predicted output and your true output, right? Essentially, it's a difference between what you want and what you have. And that error is something you want to minimize, right? Because minimizing it is the way to get to what you want, right? Rather than what you have right now. So there are many kinds of cost functions that I won't go into right now, but all of them essentially come down to this fact. They're a measure of the error between your predicted output and true output. The reason that there are many different cost functions is that you would want to emphasize different types of error in different scenarios, right? For example, let's say you're working on a regression problem. You're more interested in cost functions like mean square error and so on. If you're more interested in classification, then you'd use something like binary cross entropy loss, or multi-class cross entropy loss, and so on. The reason for these differences is simply a lot of experience, right? After a lot of experience, you understand that some cost functions derive better results, and of course there are mathematical reasons for that as well, right? You need to go deeper into the mathematics to understand that. And finally, now that we have an estimate of how bad our model is doing, what we do is we go backwards, as in from your output, let's go backwards and trace where the error came from. What parameters do you think should be modified, right? And often backpropagation in many courses is described as a very difficult, very complicated process, but very intuitively it comes down to this. Let's look at the green arrow here, right? And this green arrow is pointing to the weight, as you can see here, as I'm outlining, between this red neuron of the first input layer and this yellow neuron in the hidden layer. Here I've taken a very, very simple neural network. So let's look at this particular weight, all right? So remember, we talked about tweaking parameters to make our predictions better. We're essentially going to do exactly that. So let's maybe let's toss a coin and say let's increase the weight joining the first input neuron and the first hidden layer neuron. All right, let's increase this weight. If we increase this weight, we know that this prediction will end up slightly differently, because this neuron will be slightly more influenced by the first neuron and hence will contain a different value as compared to what it used to. And similarly, therefore, this final pink neuron will contain a different value than what it used to, right? So your predictions will be different, and because your predictions are different, there is either only two choices, right? There are only two choices. Your predictions are either better or they're worse, right? So if your predictions are better than before, that means your cost function or your error between your true outputs and your predicted outputs is smaller. So if the cost function decreases, then you've essentially gotten better at prediction, right? So that's exactly what you need to do. So you would want to increase this weight more, right? Rather, if the cost function increases, then I need to decrease the weight here instead. I hope you understood the logic, right? If the cost function increases, that means your predictions are getting worse. And what you actually need to do is the opposite, right? You need to decrease this green weight instead. So back propagation, the idea of back propagation or learning essentially comes down to the fact that every weight has a contribution to the prediction, and modifying these weights or tweaking these weights gives you different predictions. And what do you think? And back propagation helps you determine what ways can I tweak all these weights so that my prediction becomes the best as I can, right? And here I'm taking only weights as an example, but in reality we need to ensure that we train all the learnable parameters including biases. So does anyone have any questions until now? This is generally I'm sorry, I know that I've rushed quite a bit. I'd actually like to take a lot. I would have liked to take a lot of time to explain much more slowly, but I think a lot of you are interested in knowing about the hackathons, some certain rules, and some of the doubts you may have about the hackathon. So I want to get into that. But before I do, does anyone have any doubts? I'd like to take a few minutes to clear those out. Can anyone respond about what you may think? Are you able to hear me? Um, Let me check. Okay, cool. All right, sure. I was just confirming. All right. Okay. All right. If no one has any questions, I think it's understandable because a lot of you are probably, because you're interested in this hackathon, you might have participated in hackathons before. Actually, before I do that, I actually do want to get a sense of how many of you have participated in hackathons. So, could everybody who has participated in at least one hackathon before, can you please raise your hands on Google Meet on the Meet? Okay. So wait, I have a question from Mitran. Yes. If a coin is tossed, only two possible outputs are given. Only two possible outputs are given. How can the weights be increased? Okay. Okay. Good question, Mitran. So sorry, guys. Keep your hands up. Everybody else, if you've not been able to hear me before, if you have participated in at least one hackathon, please raise your hand. So I'll get a sense of how many of you are experienced in that, in doing so, right? Otherwise, I'll go over the procedure as well a little bit. All right. So meanwhile, I'll be clarifying that question. Yes. Anyway, some of you wanted to. All right. So basically, the thing is, even though only two possible outputs are possible, you're right. It can be either a head or a tail. So your output neuron will be either a head or a tail, right? It'll contain a number which will predict whether the coin toss will be a result of a head or a tail, right? Because by the way, here we are assuming that coin tosses are biased in some certain way, and you're given a data set about different aspects of the coin, maybe the thickness of the coin, the quality of the coin, the way the coin is tossed, and you're finally given the list of all the target variables, as they are called. Target variables are essentially the true values for you to predict your hypotheses against, right? So your final neuron will be some probability with which you think that the coin toss will be a head, say, right? So you might be wondering, how can weights be increased? That's a good question. Essentially, the weights are parameters of what you define as a model, right? And what you define as a model is completely up to you. It's not constrained in any way by the data that you're using. The model the way you define your model can contain any number of it can contain of course, it is the number of input points determine how many neurons you use to take in that data, and the number of outputs that you require constrain the number of output neurons that you need to have. But whatever is in the middle, as in whatever you use to process the connections between the inputs and the outputs, is completely up to you, right? So you can have as many weights as you want between any of these hidden layers, right, to appropriately process the input data and predict good outputs, right? So that way, just because there's only one neuron doesn't necessarily mean that there's only one weight, because there could be many other neurons in previous layers. So I hope, does it answer your question? uh okay, sure, we'll have I will find out whether the producer for this hackathon is also willing to speak, um, and by the end of the session we'll see if we can have a small word. Sure. So okay, fine. In that case, I can see that there are some hands up. So all right, so a lot of you okay, fine. So maybe 3 or 4 out of the 60 people, right? That's not a lot of you, but it's fine. I'll go over. So some of you I know might be slightly bored of all of this, as you might have known a lot about this. So we'll slightly get into the little bit of the technical aspects of the hackathon itself. So if you have any doubts there, you can definitely ask. So coming to the hackathon, the idea is that apart from learning the theory, right, which I've noticed a lot of people in AI do, it is very important to also implement whatever you have learned in theory, right? So I'll just take a small moment to explain a little bit about how you would implement an AI model, and I'll share this with you. So I won't spend much time on this, but so okay. So basically, the idea is that there are very simple steps, right? And a typical a model would look like this. So you'd import necessary libraries that will help you process the data, right? You read the data that's given to you. You would analyze the data. So I'm not getting into the specifics because I know a lot of you might be waiting for the hackathon. If you have any doubts in this section, we'll come back to it after we discuss the hackathon. So I'll just go over this very briefly once though. And a lot of people gloss over this aspect. It's called exploratory data analysis, and I think it's a very important aspect. You have to get a feel for the data. You have to understand the data, visualize it, and see what kind of patterns you can detect early on in the data. It'll help a lot in terms of you know it'll help a lot in terms of using your own understanding of the data to appropriately determine the parameters of the model, appropriately determine the architecture of the model, and some other things which are not under your control, which are not learnable. Sorry, that's what I meant. So basically you make various kinds of plots and you try to get a sense for the data, as you can see here. Next, you define your input features and your targets, as in what are all the features that determine my outputs and what are my outputs themselves, right? Then you do something called train test split, which essentially is a way for you to train your model on some amount of data and then validate it on some other data to ensure that it is performing appropriately, right? You don't want to blindly train on the entirety of data and just leave your and just keep wondering what you think the accuracy for the model will be. So then you define your model. In this case, I've used a very simple sklearn linear regression, but in practice, people are I mean, seasoned hackathoners will be doing using a slightly more complicated models. Next, you train the model, and in scikit-learn, it's a very simple dot fit, and you just fit the training data and the test data. Once you train your model, make predictions using the model and store those predictions in some array. While you're at it, it's also a good practice to look at the error between your predictions and whatever your test data is, or whatever your true targets are. And finally, if it's satisfactory to you, if the accuracy is satisfactory, then submit your predictions by writing it into a file. So make it into usually a pandas data frame, and then write it into a CSV file. A CSV file, by the way, is a comma separated value file. It's a general accepted format for submitting a file into a hackathon. So that is generally the procedure for implementing any AI model. If you have any doubts, we can come back to this later. But I think a lot of you might be wanting to go to the hackathon itself. So, are there any questions as of now? Okay. All right. I'll take that as a no. All right. So we'll come to the hackathon. So essentially, this hackathon is about predicting the number of deaths in during the COVID-19 pandemic period, right? So I list let's before I get into it, let us see if you guys have any doubts related to this. Does anybody have any questions? All right, sure. All right. Fine. Then I'll just go ahead with the I'll just go ahead describing the hackathon. So so you can read. So firstly, Kaggle is the platform that this hackathon is hosted on. So for the uninitiated, Kaggle is a very popular data science platform for people to learn, and basically do competitions. So Shastra magazine also hosting. We are also hosting our competition here. So basically, you can. So I hope everybody is registered on the competition website, right? There's a website. There's a competition website for Shastra magazine. We hope you have, all of you have registered there, right? Or I think a better question would be, Have any of you not registered for the competition yet? If not, if not, please raise your hand. Okay. Yes. All right. Sure. Okay, sir. So all of you have registered for the hackathon. So I hope then you've also entered the competition here on Kaggle. So both of them are independent. You have to you have to use your mail ID which you used for registering in the Shastra magazine website to enter into the hackathon here. So basically there are the hackathon is released 2 days ago and there are 5 more days to go, but I think we'll consider extending it for 1 or 2 days extra, maybe even 3 days, if some people want to get into the groove of understanding what this is and so on. So a general description of the hackathon is that it's about predicting the number of deaths in a widespread pandemic, right? And some primary the motivation for giving you such a problem statement has been described here, because as young data scientists, it's essential to understand healthcare is a very important application of AI, where not just in medical surgeries where you would like to use precise techniques, but also in this kind of predicting the resources required for a certain, say, set group of hospitals at a certain time when you have a widespread pandemic going on, for example. So this is a very important application, and hence I think it's a very relevant problem statement to work on, and it has some interesting challenges as well. All of that is from the all of that serves as a motivation for giving you the problem statement. But a lot of you will probably be interested in the evaluation metric, right? The evaluation metric is the modified mean absolute percentage error. A lot of you may be knowing what mean absolute percentage error is, MAPE. Mean absolute percentage error is simply, let's say, for example, let's say AI is the ith is the number of actual number of deaths, the true targets for say the ith datum, okay? And let's say Fi is your predicted number of deaths from your model. So the mean absolute percentage error, what it does is, for every ith datum, it takes the difference between your prediction and your true target. So it takes AI minus Fi and divides it by the true value, divides it by AI, right? And it takes this ratio essentially, AI minus Fi by AI, as you can see here. And basically it takes the modulus of the error. It doesn't care about whether it's positive or negative, and it simply adds up over all the data, all the test data. And once it adds up over all the test data, you divide by the total number of data points. So that's your mean absolute percentage error. You can see why it's it's a very well it's very intuitive to understand why this is a percentage error, right? So this is a very popular evaluation metric for many competitions. But what we thought was we needed to do something slightly different, right? So the idea behind this modified metric is that we want to penalize under predicting deaths, right? If you tell a hospital that in the next 1 month there will be say some 20,000 deaths or something like that, and there actually ends up happening the fact that 30,000 people die, then that's a really bad place to be in, right? Because if you have said that if you are predicting that 40,000 people are going to die and only 30,000 people end up dying, then yes, you have wasted the resources, the hospital's resources a little bit, but not at the cost of human life, right? So while that is also not ideal and you'd like to get zero error, under predicting the number of deaths is a significantly worse situation, and hence we wanted to penalize that more. Hence you have this penalty factor multiplied here, which is essentially a factor about how how negative your AI minus FI is, right? If your prediction is far more than the actual number of deaths, then you're penalized. Your error increases essentially. So that's the logic. Also, please note that since the score is derived as an error, right? A lower score is better, like golf, right? Most of you, I mean, having done hackathons, might have seen some measure of accuracy as your score, right? A lot of you will be, lot of you might even colloquially be referring to getting 100, right, as a score, and you're all be waiting for the getting 100. And in intense hackathons, that is generally the case, yes. But here we have chosen to give you the error as a score, and therefore a smaller error is better. Also, please note that the leaderboard calculated here is calculated with all of the test data, and there are no separate public and private leaderboards. Oftentimes, sometimes what happens is that competitions will have a separate private test data and a public test data, and they will only evaluate the predictions, submitted predictions on the test date, on the public test data, and generate a leaderboard about all the people submitting the things. And then at the end of the competition, they'll also incorporate the private test data, and together they will basically generate a new leaderboard, right? We haven't chosen to do, we have chosen not to do that, because this is probably the first hackathon for a lot of you, and it might be intimidating to understand all of these various aspects. So instead, don't worry, whatever score you've gotten on the leaderboard currently is your final score as you keep getting better. So there's a small process after the hackathon, after this happens, after these couple of days. The top 30 teams in the leaderboard will be selected, and these selected teams should make a 2-page report explaining their method, experiments, and results. So let us say let's say you're using some sort of say stacked model. Okay, I'm just throwing some names out here, so don't worry if you don't understand what these are. So let's say you're using some sort of a naive base, and you use a logistic regression stacked on this, okay, or linear regression stacked on this, right? And you make some predictions, and let's say that your predictions are kind of bad, they haven't turned out very well. You're recommended to still write about your experiments in that 2-page report. Okay, if you're in the top 30 teams, then you should make a report, and these reports should contain experiments like these. You should intuitively explain why you use that certain model, right? Why you use a certain optimizer for back propagation, why you use so many epochs for training, all of that. You don't need to go into every single detail, but it's generally recommended if you have thought about some aspect of what you're training or using, it's good to mention them, right? If, for example, do mention about all the hyperparameters that you're using. Okay, the values of the hyperparameters. Why have you chosen a certain hyperparameter, right? All of those are expected to be in the report. You should also add your method, your final model, a description of the final model, preferably an algorithm, right, of your final model. So if you've used a certain model, you should make a flow chart, explain how the data process goes through the architecture, and then you make predictions. If you have looked at some papers in AI, you may have seen architectures for models like RetinaNet, ResNet, YOLO, so on, right? So we're not expecting something as comprehensive as that, but something similar, right? We want to have a flowchart kind of description of your model and how information progresses in different layers. You should submit this report and your code along with instructions on how to run your code. So essentially what we'll be doing is we'll be taking the top couple of submissions, and we'll be looking at your report for each of these errors and your codes, and we'll determine the winners based on how innovative the solutions are. So we don't only care about your final score, but we also care about how innovative your methods are, right? Because a small score increase is still not worth losing out on a far more innovative method, because the innovative method may be more general, right? You may be robust to changes in the test data, the input data, right? All of those aspects make your model a better model if they are more innovative, if it's more innovative and well thought through. So we're expecting something like that. So make sure you don't just plug and chug, as it's called. So what happens is, uh, in this hackathon and in most, you're given approximately 5 submissions per day. As in, you can make 5 prediction submissions, and you will get 5. Since you're all probably in the hackathon already, you know this, but you will get 5 different evaluated scores, right, of your predicted submissions. So generally, what happens at the end, in the last couple of days, is that you have run out of new ideas to build a new model or improve it in any way. So you just start changing small values in your submissions, and you hope you get a better score, right? Uh, that is generally not recommended, because we'll anyway find out in when you submit your code and your report, right? When you submit your code and report, and if it doesn't contain any innovative thought, then no matter how high your score is, you will still not be considered for it, for getting a prize. So that is not recommended either. So try to think about it. It is definitely a very fascinating process. uh, Use the internet. There are many resources available, many resources available. I have added some myself, but they're granted pretty basic. uh, you can always contact us if you have any other questions. So that is about the overview of the contest. Do you have any questions as of now? Okay, sure. uh, I'll uh, briefly talk about the data. So here you can see the data here, right? And I have written a small description on each of the files in the data here. Uh, so take the training data, for example. So you have 11 columns, 10 features, and one target. So your targets is deaths here. Okay. uh, and basically, there are of course some missing values in the test data. For example, if you take the test data, so all of these are there's no data here. You can see that it's basically blank. So handling blank data or missing data is a very important process in ML, and this is an opportunity for you to learn the same, right? If you want to go read up a little bit about it, search imputation. Okay, imputation. So anyway, so the idea is that you have to first understand the data, visualize it, go through different ways of visualizing. Clearly, I mean, I won't tell you some any methods. I mean, it's up to you to figure out, right? Um and once you do that, uh, devise an appropriate architecture, appropriate neural network. It's deliberately made very simple. Okay, so if some of you are very experienced, you may be wondering, you may be thinking that this might be slightly on the easier side, right? Because but I've deliberately chosen this because a lot of you are new to AI, right? So a lot of you might be intimidated by it. So this hackathon is specifically curated for you to ensure that this is a smooth learning curve, right? There are provisions to ensure that we haven't, gone overboard on the kind of difficulty that we're asking for. So this is a general description of the data. You can see actually that Kaggle has a very nice outline of the data itself. So you can clearly see that it will tell you some aspects of it. So it'll tell you the mean, the maximum, the minimum, right? The standard deviation. All of those, all of that information is available here. You just have to look at it. So you can go through all of that. In this competition, you don't need to know metadata. Metadata is basically data is basically information about the data set itself. Okay, and that isn't something that you require this for this time. Discussions. Okay, we'll be answering questions here. So yes, definitely post them if you have any questions. Coming to the leaderboard, there are a few. There is a small problem here. So initially, what happened is in our evaluation metric, there is a very small problem that allowed for negative scores. So we have since fixed that, and now there can't be any negative scores. So are any of the four of you here right now in this meeting? Yeah, so there are no possible negative values for the score here now, henceforth. Remember, in the evaluation metric that is explained in the overview section of the hackathon, the entire error is wrapped in an absolute value, right? So whatever your score is, it has to be positive. The reason for those 4 negative values was a small mistake in the evaluation metric code. Because this is a custom metric code, there's a small mistake there, but we have since corrected for it. So basically, there are essentially 4 people who have gotten negative scores, and if any of the 4 are here, what you need to do is, henceforth anyway you can't get negative values for scores. So at the end of the hackathon anyway, you will be asked to select 2 of your best submission files for submission, right? And Kaggle auto selects the best 2 scores, right? But we specifically request you to not take the model which gives you the negative score. Okay, because now that we have updated the evaluation metric, we'd want to only consolidate the positive scores. So if you're here, please don't select any submission which has negative score. Okay. Can you increase the submission to 10 per day? We'll consider that, and we'll get back to you in some time. Submitting
Thank you.
Sure. Submitting CSV is enough, right? Which is predicted from the test data. Yeah. Your submission file should be in a CSV format. Actually, there are a few other formats that Kaggle accepts as well, but the most common is a comma separated value format. So, and that is enough. Exactly. Evaluation will be done by the Kaggle based on our code. If there's a team of 4 members, while submitting the results, whether a leader has to submit. So okay, when you make a team, all of the team members together get 5 submissions per day. So you'll be able to submit through the team. If either of you submits, it'll count for a submission, submitting a file. So I'll come to your question one second. So if you have 4 members and all 4 of you cumulatively have 5 submissions, that is what it means. So any of you in the team can submit, but it will accumulate for the entire team. So keep that in mind. So individually ensure you plan with the rest of your teammates before making any submission, right? Because it affects the entire team. So ensure you do that. No need of submitting code? No, not as of now. So after the hackathon is over, we'll take the top teams and we'll ask them to make a report and submit the code. So right, yes, do preserve your code. Don't delete it right after making a few submissions. preserve your code, and if you are in the top few teams, you will be required to submit your code, so make it neater. Then if you want, if you're anyway in the practice of committing your code and basically making it neat and defining variables clean, then that's good. But if not, ensure that you do it once the competition is over. Yeah, so are there any other questions? So that's the leaderboard. Coming to the rules, I hope these rules are okay. So you have read through the rules. So the maximum team size is 4, and each participant must be only a part of one team, and your team name on the leaderboard must contain the name of your college and the name of one of the team members of your team. So here, basically, we have noticed that not a lot of participants have followed that rule, but we seriously require you to follow that rule. All right, because that will be considered while giving prizes. Violation of any rule may lead to the disqualification of the entire team. So Shastra, we reserve the right to change rules and appropriately determine what to do when rules are violated. So essentially, that concludes the description of the challenge. If you have any other questions, I'll be happy to answer it. So yes, the video for this session will be sent to you. Uh, so it will be sent to you. Yeah. Okay. Yes. All right. So I will explain how to create a team. So okay. So on if you go to Kaggle and you go to team, right? You can see you can first modify the team name. So you can call it your advice to call it your name underscore your college. Okay. So you're recommended the rules are to follow this format. So once you make a team name, you can add you can send invitations to other people. So everybody should create a Kaggle ID, so a Kaggle account, and once you create a Kaggle account, you can add people into your team. For example, I can send requests to other team members, and if they accept, then they'll be a part of my team. Once they accept, they'll be a part of my team, and that's essentially it. If you have personally received invitations from any other teams, that'll end up showing here. That'll show up here. So you can click on accept or decline whether you'd like to be a part of the team or not. So that is a procedure on how to create teams. I hope that's clear. Uh, can explain that? Can you explain the team name format? Yes. So the team name format is your name underscore your college, and your name could be any one of the team members or any one of the 4 team members. That's up to you guys to choose. Uh, is there any possibility of extending the submission date of the hackathon? Yes. So we will mostly end up extending the hackathon submission date, the final date by 2 or 3 days. Yes. So Manoj, I didn't get your question clearly. It will be helpful for us to do the project. What project are you referring to? Okay. Yes. The leader should send invitations to only to those members who have been registered as teams at the time of registration. So in the Shastra magazine, in the portal, you would have registered with 4 people, right? So any one of those 4 people have to now be the team leader and send invitations to the other 3 members. So I will talk about. I'll just go over the process again. So look, go to the team section in the AIML challenge page. Here you will see something like team name here, and here you need to make your team name. So for example, if I choose to be the leader of my team of 4 people, then I will say Atreya underscore IIT Madras. So that will be the name of my entire team, my entire team of 4 people. Now once I create the team name, I can add 4 people now. So I must send invitations to the other 3 team members to join. For example, if I wanted, I can send an email to maybe. So essentially, I can send invitations to anybody that I like to. So for example, if I've registered with say Srikant, Mr. Srikant K, then I can send an invitation to Mr. Srikant K, and because we've already registered as a team on the Shastra website, he'll accept, and we'll be a part of the team then. So both of us will then end up being a part of that team. Similarly, I have to send invitations to 2 other people, and they both have to accept. Therefore, then all the 4 of us will end up being one team. Now, as a team, any of us can make submissions, and if either of any one of the 4 of us makes a submission, that will count to the submission of the entire team. So ensure that before you submit, you talk to the other teammates and ensure you don't like waste all the submissions. Do you have any other questions? So if you do have any other questions, please feel free to put it up on the discussions forum. We will answer it. And we'll also keep in mind about extending the number of daily submissions per team. And we'll also extend the submission date of the hackathon by a couple of days. So other than that, I hope everything is clear. For those 4 teams with negative scores initially, please ensure that you select your best 2 submissions as ones with having positive score. And another point of note is that the smaller your score is in magnitude, the better you're on the leaderboard. That's why I hope that's clear, because the score is a measure of your error, not your accuracy, unlike other competitions. Yes. So I think if no one has any other doubt, then we'll wrap up for today. Nana, Nana. నాకు తెలియదు ఆయన నంబర్ లేదు నా దగ్గర. యా అన్నా సో అడగనా బాగుంటుందా ఇంట్లో ఎవ్రీబడి ఆ ఆ ఆ So yeah, if there are no more questions, I think we can wrap up. So All the best for the contest, and see you.